Okay, we're doing 6.6 in Algebra 2, and we are going to be solving some exponential equations. So the first example we're going to do is 100 raised to the x power equals 1 over 10 raised to the x minus 3. So the first thing I want you to notice is that both of these are a power of 10, and I'm going to rewrite them. I'm going to write this as a power of 10, which would be 10 squared. 1 over 10 is really 10 to the negative 1. So notice now that they both have the same base there. And now I'm going to apply the power of a power on exponents. That means if you're raising a power to another power, you multiply the exponents. I'm raising this to this. I'm going to multiply this by this whole thing. I get negative x plus 3. 2 times x is 2x. So remember the property of equality for exponential functions, that if b raised to the x equals b raised to the y, then those two exponents must be the same, right? So that's basically what I have here. 10 raised to the 2x is equal to 10 raised to the negative x plus 3. That must mean then that 2x equals negative x plus 3. So I'm going to go ahead and just write that down and then solve for x. I would add x to both sides, which gives me 3x equals 3. Divide both sides by 3, and x equals 1. All right, next problem is 2 raised to the x is equal to 7. Remember, the reason that logarithms were invented was to solve problems like this, to undo these variables in the exponent. So I'm going to take log base 2 of both sides. So the log base 2 of 2x equals the log base 2 of 7. Remember, we can do whatever we want to an equation as long as we do the same thing to both sides. And then don't forget our inverse properties, that log base 2 of 2, when these two are the same, it simplifies to whatever that exponent is. All right. And if you have a TI-84, you know that log base 2 of 7 is 2.807. If you don't have that, then we're going to use the change of base formula to do it on whatever calculator we do have. So remember that the change of base, I can say the common log of 7 divided by the common log of 2 is going to equal that. And I just do this on the calculator, and you're going to get approximately 2.807. All right. Okay. Also note the property of equality for logarithmic functions. If log base b of x equals log base b of y, then this has to equal this. Makes sense, right? Then x equals y. So notice that the natural log, if the natural log of this equals the natural log of this, then this must equal this. And I would just set it 4x minus 7 equals, set it equal to x plus 5. Solve for x. Let's see, I would subtract x from both sides and add 7, which leaves me 3x equals 12. Divided by 3 gives me x equals 4. All right, here's another example. Solve log base 2 of 5x minus 17 equals 3. We're going to exponentiate both sides. Remember, we did this in class the other day. So I can take 2 and raise it to this whole thing. But then on the right-hand side, I have to take 2 and raise it to this. And that's called exponentiating both sides. So 2 raised to the log base 2 of the quantity 5x minus 17 equals 2 raised to the third power. Okay, so remember this rule, that when this and this are the same, it simplifies to whatever's right there. So when this and this are the same, simplifies to that right there. So 5x minus 17 equals 2 to the third, which is 8. I'm just going to add 17 to both sides and then divide by 5. Easy peasy, huh? Okay, solve this one. Log, the common log of 2x plus the common log of x minus 5 equals 2. So remember when I have the same logs with the same bases, 10, there's really a 10 there, and this is adding, it's the same thing as log base 10 of this times this. So I'm going to go ahead and write that. And remember, this is the common log is really log base 10, right? We just don't have to put the 10 there, but I'm going to, just in this case, because I want to exponentiate both sides. I'm going to raise 10 and raise it to this. That's going to equal 10 raised to that. Well, let's do the right-hand side first because 10 squared is 100. But remember, when this and this base are the same, it simplifies to that. So now I'm going to just multiply 2x out, which gives me 2x squared minus 10x equals 0. I want everything, or equals 100, sorry. I want everything on the left-hand side and set it equal to 0, so I'm just going to subtract 100 there. 2x squared minus 10x minus 100 equals 0. Well, these all have a common factor of 2, so I'm going to go ahead and divide everything by 2. And when I do that, the result is x squared minus 5x minus 50. Well, this is a quadratic. It's a quadratic function, and I know that this can be factored. How do I know that? Just by looking at it. Well, I'm a really good factor. Some of you might want to work on the factoring skills. So it factors to x minus 10 times x plus 5 equals 0. And we know that we just set each factor equal to 0 and solve for x. X minus 10 equals 0. X would have to be 10. X plus 5 equals 0. X would have to be negative 5. So there's two answers to this one. Note, my note here, it says skip number 19 and 20. You don't need to do those. So what do we do when a common base cannot be found? For instance, this is a problem where a common base is not going to be able to be found. So what you can do is graph each side as if they're separate functions and look at the intersection. So the intersection, remember, can be found by using the second trace button. Remember, the calc is above this. And you could just calculate the intersection by going second trace. And when I did that, found the intersection of, this is 4 raised to the negative x plus 5. And this is the natural log of 3x. Here's where they intersect. X is approximately 4.321. It's generally accepted, I guess, when you're doing logarithmic functions, that you round to the nearest thousandth. Okay. So you might want to make a note for this for number 18 on your worksheet. There's 4 parts to it, A through D. A through C, you're going to use the compound interest formula, remember, from 6.2. For D, you're going to use the continuously compounded interest formula, also from 6.2. And for A, the number of times compounded is 1. For B, the number of times a year it's compounded is 4. And C, the number of times it's compounded is 366. So when it says it's compounded daily, instead of using 365 financial problems, we use 366. And then a final note to skip section 7. We're not doing that one. All right. That is it for section 6.6.